So today we're going to talk about how you can find local minima and maxima for a function or an expression like y is equal to x sine of x using the fminbnd function. Now in the last video we used the same expression y is equal to x sine of x, and we found the local minima and maxima using the min and max functions. Now this time we'll use the fminbnd function, which is, in my opinion, is easier to use, and it also when finding the maxima, it requires like a thought process as opposed to just plugging in things into equations, into functions. Okay, so just like the last video, we have x is assigned linspace 0, 6, 101, meaning that x is a vector that goes from 0 to 6. And it has 101 total elements in it that go from 0 to 6 inclusive. Now our function f is assigned at x sine of x, this is our function, and this is what the graph looks like. So since the first thing we'll be finding is the local minima, we can see from the graph that the local minima occurs at x is equal to about 5, and then y is equal to about -5. So that's what we'll be hoping to get when we after we write our line of code, to get something about 5, -5 or something close to it. So on the right hand side, you write your fminbnd function, and inside the function, the first thing you will write is your function handle. So in this case, our function handle is f right here. The next thing you will write is the lower bound for your function. So our lower bound here is 0, so I'll write 0. Then you will write your upper bound. Our upper bound here is 6, so I'll write 6. And that is all you need to write for the right hand side of this equal sign. On the left hand side, the first thing you will write is the variable for which you'll write the variable for your x at the minimum, your x value for when the minimum occurs, and then comma, you'll write your variable for the y value, or the value of y when the minimum occurs. So what the xmin will give you is this value right here, the x value at this point right here, and then what the ymin will give you is the y value at this point right here. So finding the minimum or local minima is the easiest thing using when you use the fminbnd function. Things get complicated when you're trying to find the local maxima though. So if you look at the graph again, we estimate, oh actually I did not run this, did I? Let's run this and check our answer just to see if we're right. So we expected xmin to be about 5, so this is precise, so this seems right. And then we expected ymin to be -5, I think. Ymin to be -5, yeah. And so -4.81 seems close enough. So we can assume that our estimate was right. Now, if you're trying to find the local maxima, we see that it should be around 2, 2. So for your x is equal to 2 and your y is also equal to 2. Okay, so the first thing you do when you are trying to find maxima using the fminbnd function is you declare a new variable g, which is assigned at x. So g is a function handle now, and then you assign it the negative of your function. So now, since our function was f, we're going to call g is assigned at x negative f of x. Now from math, you might remember that when you make a function negative, or when you multiply a function by -1, what it does, it flips the function across the x-axis. So what this will do is it will create a function that looks something like this. So your highest point is now your lowest point, and your lowest point is now your highest point. That's basically what it means. So the first thing you do is that if I graph this, let me graph this real quick. Plot x comma g of x. You see that this function right here is the reflected over the x-axis. So that's basically all it means. It's reflecting over the x-axis. The scales are a bit different, so you might think that they're not reflected, but you can see this point right here is the same thing as this point right here. I mean this curve right here. So it's just a reflection over the x-axis. Now once you write g is assigned at x f of x, the next thing you will do is go on and use the fminbnd function. So on the right hand side you will say fminbnd. The first thing again that we'll write is your function handle. Now our function handle has changed to g, so we'll call it g, comma, lower bound is still 0, upper bound is still 6. On the left hand side, now you know the new minimum. Where did it go? Okay, right here. We see that our new minimum was our original maximum, so we can use, what we'll do is the first thing we'll write is x max. So this will give us our x value when the maximum point occurs in the function. Now here you'll write, I'll call it negative y max, because what this will give you is this point right here, and it's the negative of what your actual point was. So if you multiply the y value at this point by -1, it will give you this point right here. So for now, what we will call this is negative y max. And when you run this code, you see that you get x is equal to 2. We expected to get 2 comma 2. So let me write that down here. Expect to get 2 comma 2, and we got 2 comma negative 1.81. And if you look at the function, not this one, if you look at the original function, you see that the x value should be 2 and the y value should be about 2 and not negative 2. So what we'll do is we'll call this y max is assigned negative of negative y max. Sorry for the terrible variable names, but I mean the point is so that this negative crosses out with this negative and leaves you with y max. That's what my thought process is. So when you run this, you see that your x max is 2.0288, which is what we expected, and your y max is negative 1.8197. So this is how you will find the maximum. It's a bit complicated, but if you know the thought process, you can easily do it. Thank you for watching. See you next time.